Okay, so topic 5 for computer programming is about conditionals and indexing. So these are two relatively interesting topics, and it's quite an easy topic, this actually. It's fairly straightforward. So first of all, conditionals. A conditional statement is something that's made up of 3 key components. Okay, now what we'll do is we'll just revise first of all what actually is a variable. So last week we looked at variables, and a variable is just a box in the computer's memory. So we can do my variable equals 5. Okay, I'll use the actual equals sign. And then if we just do print, okay, my variable, press tab even, it'll print back 5. And we can also, as we know from last week, we can nest functions inside each other. Okay, so we can print the type of my variable as well, and we can see how the computer is going to treat my variable, and it says that it's an integer. Great. So let's just crunch those together and we'll add a new cell underneath. Okay, so a variable is just a reference to information in a computer's memory, and a variable has a particular type. So what's a conditional then? So in computer science, a conditional statement or conditional expression is a construct and feature of a program, of a programming language. And basically what we do is, and this is kind of the dictionary definition here, we perform different computations or actions depending if a Boolean condition is true or false. Okay, so why would we use a conditional? So conditionals give us the ability to test a variable against a value and act one way or the other. So in pseudocode, alright, this would be if something's true, then do something if it's true, else otherwise do these things for false. And the condition can just be anything that evaluates to true or false. Now, the key components of the conditional have names. Okay, and those names are the predicate. Okay, what is something predicated by? And that's this bit here, A, is the predicate. Then we have the consequent. So what is the consequence of the predicate being true? And then the other is the alternative. Okay, what happens if it's false? So that's the kind of structure. Now, in Python, it's incredibly easy to create these statements, okay? So I've got an example here. We have temperature is equal to the input of an integer. What's the temperature? If the temperature is greater than 15, which it very rarely ever is in Scotland, print, I don't think you need a coat. Else, print, wear a coat. Get some exercise outside, some fresh air. That's just a humorous statement I put there. So let's look at an example. I've already created a variable called my variable equals 5. So let's say we want to test if my variable is greater than 5, or greater than 10. So all we do is we just write if, and then we say the name of the variable, my variable, and then we want to give it some kind of test, so we're going to need an operator. So let's just say greater than, and let's say greater than what? Greater than 10. And then what we do, we need to tell Python that we're about to give it the consequence, okay, what to do if this is going to evaluate to true. Okay, so we just do colon and press return, and Python will automatically indent us by 4 spaces. Okay, and that shows that we're now providing the true part. So if my variable is greater than 10, print, okay, it is greater than 10. Okay, so let's run this and see what happens. Now, we know that my variable is 5, so it's not going to do anything. So let's just run this. Okay, nothing. Now, this else part, right, we don't have to provide that in Python, okay? What this is if my variable is greater than 10, do this, and then there's an implied else, do nothing. But we don't have to write that out. It'll just understand that it'll say else, we don't do anything at all. Let's change the value of my variable now to 11. and let's just enter that into the computer's memory. Okay, so now if my variable is greater than 10, print it is greater than 10. Let's run that, and there we go, it prints out it is greater than 10. Okay, now let's just add on the alternative part to the statement. Now to do that, at the moment we're still indented here, okay, so we need to go back to the first column, okay, back to column A, and write else, okay, and then do a colon and then press return, print, and just say it's less than 10. Okay, so let's run that. It'll still be greater than 10 because remember my variable is still 11. Let's run this. Okay, it's greater than 10. Let's make it 9 and see what happens. Change it to 9. Send it to the RAM. Run this. Now it's less than 10. Okay, so that's the alternative solution. The alternative part. So going back to the flowchart, we have our predicate. If my variable is greater than 10, we have the consequent. What's the consequence of that? Print it's greater than 10. And if it turns out to be false, which it is in this case, we have the alternative solution. So what actually happens in the computer program is it's going to read down the program one line at a time. Remember, it can only do two things: perform a calculation and store the result. And then suddenly we're going to say stop. Test something and then do something else. So the computer will stop running the program line by line and it'll enter into this test situation, and one way or the other it will come out. Okay, so there's my example there. There's an example with an if else that I've just shown you. There is another thing that we can add, okay, and that's called an alif, right? And this is like another alternative, and we can pop this in the middle here. So let's just go back and do elif, okay, and we'll do return, print it is 10. Okay, so the three situations we can have is the variable could be greater than 10, it could be 10, or it could be less than 10. And let's run that. Still going to be, yeah, okay. So what we have here is a situation where we and what we can actually do is we can actually have elif, 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 elif. We can have loads of these. Okay, we can stack them. The only rule is the last one has to be else. Okay, so you could have 100 of these if you like, 100 elifs, but the last one has to be else. Okay, so we can put in as many conditions as we want there. So for example, if you imagine if you made like a menu system or something, and you said to the user, input a number, and then like choose an option. So the user chooses option 5. You could have if user enters number, if number is 1, do this. LF2, do this. LF3, do this. LF4, do this. LF5, and you could have the logic for each selection in the menu stacked under all these LFs here. So that's the LF else situation. The next topic is about indexing. Okay, so I'm just going to collapse these down here. Collapse these down, and we'll do clear restart kernel and clear all outputs. There, give us a bit more room. So indexing, now this is another very simple topic. Okay, every value in a Python string has an index. Okay, so if we create a string, my string equals hello, okay, and we just save that onto the memory, right? We can do this, print my string, and then we can go like this, square brackets, and we can say, give me the, now the indexing starts at 0, so give me the 0 part, like that, and it'll give me just the H there. Okay, so if we want, let's say we want just the letter E, we could have, 1. Okay, so every value in a string has an index starting at 0. Now, let's say we had a string with 1,000 characters. Well, let's look at some more options. We can also do a range. So if we do, like, say 1 to 2, 1 to 3, sorry, that'll give us EL. Now, if we take away the 1, Python will just treat this as an implied 0 before that. Okay, so run there, give us the first 3. Finally, imagine this is a very, very, very long string. We can actually use the negative index. So let's go -1, and it'll give us the last character. Okay, O. Alright, -2 would be the second last character, L. Right, so there's the negative indexing there. Right, so imagine if you had a 10,000 character string and you only wanted the second last character. You wouldn't want to have to write, give me the index of, like, so it's 10,000. You wouldn't have to write like 9,998 like that. That would just be a bit silly, wouldn't it? When you could just do -2. Give me 2 from the end. So that's indexing. And when we take out a section of a string, so in this case I've put Edinburgh Castle. When we take out a section, it's called a slice. Okay, so let's go 10 to 15. It's a funny how that gives me something different. Did I spell castle wrong? Who knows? Now, one thing I will say to you is when you're slicing these, I generally, maybe it's because I'm a little bit dyslexic or something, but I generally will misjudge this by 1 on the first couple of goes. So let's just change that there. Got it right there. Okay, so I would say that this is not an exact science. You're not going to get the exact indexing out straight away. You will need to mess about with it. Could it be that we're pulling the space there? Let's try 11 to 16. No, we're not. Okay, cool. Watch out for the white space as well, because they get treated as a character as well. Okay, so there's one more thing that we can do. Okay, and there's actually, so this is the start of the index range, this is the end of the index range. There's one more, might be worth noting that if we do that and a colon, it means from the 10th character to the end, right? So we don't even need to put the 16 there. We can just say go right to the end. There is one more, so I'm going to do something like, give me the first character to the 10th character, okay? Dinborough, right? Now, there's one more field we can add, and it's called stride. So if I go here, and I go there, and I do 2, it's going to say, I'm going to say, give me every second character, alright? So it'll give me D, N, O, G, like that, okay? If I do 3, it'll give me every third character. Okay, if I do 4, give me every fourth character. So that's the stride. And now, you don't have to add that. By default, stride is 0. So we just leave it like that. Okay. Right. Let's have a look at another function. I told you before, there's not very many words in Python. Let's have a look at the length function. So len my string. Okay, run that. It's going to tell me it's 16 characters. Len just means length. Count. Okay, so if we want to count the number of instances, so look, there's a letter E there and a letter E there. So let's do print, right, my string, and we're going to do dot count, and we're just going to say count the letter E. Okay, and it's going to say 2. We've got 2 in there. So if you're hunting for a particular character, this can be a useful, say ED. 1. There's one instance of ED in Edinburgh. Good. My string.find will find us the first instance of a character that appears. Okay, so say it's appearing at, that's telling me it's appearing at index position 0. Okay, so just a couple of questions. Now, normally if we were doing this in a kind of face-to-face classroom, I would get you to work these out, but I'll just show you them. I'll just show you them, and I'll show you how I would answer them. So, create the following string: she sells seashells on the seashore. A traditional English tongue twister, right? She sells seashells on the seashore. Quite difficult to say, I think. Although some of my friends from Mexico said this is terrible, they can't say it. So, what would be the Python code to show the length of the string? It would be print like this: len, okay, my string. Let's just take away dot find off of there, like that. That'll give you the length. How many times does the letter S appear? So we could do that with myString.find. Or myString.count would count S. What Python code would show only the second word? Well, we can do that with our index range. Okay? How would we show the last 4 characters? We would do that with the negative index, counting backwards from the end. And how would we show the characters from 5 to 11? We'd probably put something like 5 to 11 in for the range, and we'd probably get it wrong, and we'd probably have to change it to 4 to 12, or we'd have to mess about with that a little bit to get it exactly right. But we know how we could implement that. And can we count the number of appearances of sh? We could with myString.count. Okay. So that is topic 5. Now, it's a fairly straightforward topic, this. I don't think anyone's going to find this particularly challenging. What I'm going to do is I'm just going to pause the recording and just see if anyone wants to ask any questions about conditional statements, indexing, or string slicing using